Hey everyone, this is FixReef, and today we have another EB832 up for repair. Initially, this was supposed to be a normal, fairly boring repair of the 12-volt power supply, or so I thought. So because of this, you see this EB832 already partially disassembled. What I've done so far is I've upgraded all of the capacitors on the 12-volt power supply, because when I took it apart and looked at the red LED on the 12-volt power supply, it was completely off. So my first initial reaction was that the capacitors are probably busted. They need to be upgraded, and it'll probably be the end of this repair. So I didn't even bother recording any of it. However, after replacing all of 4 of the capacitors, you can see that the old Chinese ones are laying here. This is still not working. So because of this, I suspect that there is yet another problem, and therefore this might be an interesting repair to record and show to everyone. So if you haven't subscribed yet, please like and subscribe to this channel, as there will be many more of this type of content coming up. So let me show you what I'm seeing. At this point, I still do not know what the problem is. So we're going to attempt to investigate, find it, and hopefully fix it today. So when I plug this EB832 in, I observe that the 12-volt power supply seems to kind of been working. However, I'm hearing loud clicks from likely relays, and it's not fully functional. Here's what we have. It's plugged in. You can hear the loud click. Now we're going to hear another loud click. Let's look at the power supply. The LED comes on and turns off, comes on and turns off. So it turns on, gives power to the relays, relays click, and then it shuts off again. So something else is going on. Before I do any more damage, I'm going to disconnect this EB832, and my next step is going to be taking this power supply off and testing to make sure that the rest of this power supply actually works, and if not, we'll have to address that first. Okay, since I already took this power supply off, the replacement is going to be easier, but I'm still going to add a little bit more solder just to help it maintain proper temperature as I'm taking it out. So we'll start with this side out, then switch over to this side. And it's out. All right, so this power supply has the high side, 110 volts on this end, over here, and low side, 12 volts on this end. So to test this, I'm just going to plug it in over here, perhaps over on this side, so that it's sticking out, provide it with some power, and test it. So I'm not going to bother to actually clean any of these holes, because this is all going to be replaced and repaired at some point properly. This is just for testing purposes. Okay. So now this 12-volt power supply is freestanding. There is absolutely no load applied to it. If I need to, I will apply some load to test it. But right now it's freestanding, so I'm going to plug it in. This is going to be my high side, so I'm not going to touch anything here. And see if the behavior of the blinking red LED persists. All right, the power supply is on. I have to be fairly careful. Over on this side, you see that the red LED stays solid. All is good. So I guess my next step is going to be applying some 12-volt load to it to see how much it's going to be able to handle. All right, so positive over on the left, negative over on the right. Make sure that you can actually see this. All right. Okay, so EB832 is currently unplugged, so you can see that it's fairly quickly draining the remaining voltage that's in there. So now we're going to plug it in. Oh, well, that's interesting. You can see that the voltage on this power supply is jumping from 32 to 17 to back 30 to 32 volts. Well, that's a little bit odd, so let's try to add a little bit of load. Let's give it, let's not overdo this. Let's give it maybe about 300 milliamps. 350, give or take. So this thing is currently producing 26 volts. Yep, it's currently producing 26 volts under load. So that's more than double the 12 volts that it's supposed to produce. And because of this, the whole circuit is failing. We can bump up the current a little bit, and it's going down to 20 volts, and on and on and on and on. Well, to me this clearly indicates that we still have a problem with the 12 volt power supply. I still find it fairly interesting that if you turn off the load entirely, then it jumps between 30 and what appears to be about 17 volts back and forth, isolating. Something's not quite working right. So after some testing on this 12 volt power supply, it appears that the DC 12 volt output is producing variable voltage out, which suggests that something's wrong aside from these capacitors. We already put the brand new capacitors in there and it's still producing variable voltage, which suggests that the problem could be with the feedback loop going back to the PWM chip that's inside here. I'm not sure to what extent you can see that there is a chip in there, and this chip is a Chinese designed chip that it's mostly stable. I've seen it in other implementations, so it's not that bad, but it's possible that it went wrong. This chip blew up or somehow damaged, because it's still producing the voltage. It's just the voltage isn't as good as stable as it should be. It could also be a problem with the who knows, few other components. The point is that given how cheap this power supply is, troubleshooting any other issues on this power supply is not going to be worthwhile doing, because again, you can replace this power supply for about $2, $3, $4 depending on where you buy it. This is like the first time I've seen this power problem on this power supply, so I don't think it's as common as the issue with the capacitors. So my solution to this problem is going to be to actually take a brand new 12 volt power supply similar to this. It will still have bad capacitors on it, meaning that they're brand new, but they're low quality, so I'm not going to use them. But what I will do is I will just swap the capacitors onto a brand new power supply and make sure that the power supply works well. So right here, I have a brand new power supply. As you can see, it's identical to the one that we have. I don't know how to open this, so I'm just gonna rip it open. Capacitors on this guy are a different Chinese brand capacitors than the original bad ones, so I don't trust those at all. I don't see anything I recognize here, so we're not going to bother with keeping any of these capacitors in there. Trying to see what brand this is. I can't even make out what it is. So yeah, we're going to just use this as our base power supply to swap the capacitors on. We also will have to swap the pins as well, because the brand new power supply does not come with any of the pins. on both sides. So we're going to have to take these pins out, put them on this power supply, and do some testing. So let's get to it. First, I'm going to take all of the capacitors, all of the good capacitors out so that I can reuse them. They're brand new. They just are no longer needed on this power supply. This power supply will be junked once I get everything that I need out of it. All right, so it already has leaded solder in it, so all we have to do is just heat it up ever so gently. Actually, use this. So heat it up ever so gently, and this capacitor should just come out without an issue. Okay. Now I'm going to probably try to get the pins out as well while I have this power supply. We're basically dismantling everything that's in it. All right, so to do so, I'm probably gonna grab it up at this edge over here. Now the capacitors are gone, it's much easier to connect it this way. To make my life easier, I'm going to add leaded solder to these pins, to these joints, so that I don't have to fight the temperature as much. You can see that the pins are already moving. And let's take them out. Okay, nice and easy. Okay, done with this power supply. Since I can't trust any of these components on this power supply, I'm going to just junk the whole thing at this point so that it's not going to become a donor, as it's who knows what else is wrong here. Now we'll take the brand new power supply here, and we're going to take out all of the bad capacitors on it. Let me put my good capacitors away so that I know that they're not going to mix with anything. Since this is a brand new power supply, probably has unleaded solder on it, I'm just going to add some leaded solder to help me with the temperature. And in fact, as I'm doing this, as you can see, capacitors just keep falling out. Good, less work for me. Okay, 2 out. 3 out. And the last one out. Okay, so just so that we're doing the right thing, I'm going to check parameters on each of them. Okay, so this is a 25 volt, 470. There should be one more of those. Yes, 25 volt, 470. There should be 4 point. This should be 4.7. Aishi. They made it sound like it's a Japanese capacitor, but it is a Chinese capacitor. 400 volt, 4.7, and this should be 47 value at probably 25 volts. And in fact, it is 25 volts, 47. All right, so the values of these capacitors are identical to the ones that we're going to put in, so we have everything that we need. I'm going to go ahead and clean the mounting holes. All right, so next, while we don't have the capacitors on, let's put the pins in just to make life a little bit easier. So once again, these pins will likely have solder on them. We want to make sure that that solder is gone before we put them in, because otherwise they're not going to fit. This seems relatively clean, and I'm going to just do one side at this point. A nice hot iron is going to take care of that problem in no time. Okay. Now I'm just going to add a little bit of flux, just so that we have something to solder against. So what I would like to do is, on a relatively clean iron, just add a little bit of solder. All right, so they tell you not to do this, because you're supposed to solder with the apply solder to the joint, but this trick allows you to actually do this with only 2 hands. You don't need 5. Because now that the solder is on the tip of your iron, all you have to do is, and you have flux over already on the board, all you have to do is just touch the joint. The flux is going to take care of everything for you. I'm just going to make it nice and straight, as much as I can anyway. Okay, all right, so these pins are not going to be very straight right now, which is okay. We can always adjust them as we try to feed it back into the main board. But for now, we need to add our capacitors. All right. So this power supply should technically work. But before I install it into the EB832, I'm going to actually test it, because this one I don't want to give it any chance of not working on me when I'm trying to assemble all of this together. Okay, so to test this, first I need to give it some AC voltage. So I'll do something that I will never ever recommend somebody who's not experienced in this to do, is I'm going to just attach some wiring and plug it in. Again, don't do this at home. And on the, what I'm going to do on the DC side is I'm going to probably just connect my grabbers instead of this, probes. Power supply. All right, which one is plus? Okay, positive, negative. Okay, so we're gonna measure DC voltage. Hopefully you guys can see well enough. Oops, it did not work. That was unexpected. There is no way I did something to that power supply that made it catch on fire, so I have to assume it's a faulty power supply. I'm gonna try one more, but this time I'm not doing anything to it other than connecting the two pins over on the AC side. Now I'm just going to plug it in the original power supply. See if that catches on fire. Okay, that seems to be working. Let's test the DC side. The DC side is at 12 volts, so far so good. Okay, so after the fireworks with the previous power supply, I'm actually going to take time to test all of my capacitors because who knows? 46, almost 47 on this one, that's the way it should be. 470. 470. About 4.1, but it should be 4.7. So this is a little bit smaller. So this is a brand new 4.7 capacitor. It's better within the tolerance. .3. The other one was 4.09. I'm just going to use this new one because I'm not sure what's going on with the other one. What I'm suspecting happened to the previous power supply is that it might have been damaged in shipping, or for that matter, low quality component. And there is a transformer here. It's sort of a pre-filter. It's not a transformer, but it's a pre-filter on the AC side. As it got damaged, it shorted. It shorted the wires across the two pins, and that probably caused some major problem. Okay, we got another power supply now to test. All right, let's see if we get more fireworks. No fireworks this time. And now, looking at the output, it's a nice stable 12 volt output. It's not jumping anywhere. So I think we have a good power supply. disconnected. The voltage is dropping now as it's discharging. It's good, let it discharge. Alright, so I need to, here's my EB832, so I need to clean up the holes. With my super weak. Sometimes when it gets this stubborn, what I like to do is I like to take one of those things that I just cut off of my capacitor and just clean it up. All done. Alright, a bit of cleanup. Now let's try to put our power supply back on. The problem, of course, is that the pins, since they've been manually installed, may not be as straight. So before we put it in on the other side where it belongs, I'm going to try to feed it on this side to make sure that they actually feed, and if they don't, I have the ability to correct it. This side is a little bit tight, but that's because probably there's a bit of solder. That's all right. All right, the power supply is in place. One final cleanup. Okay, now it's time to test. All right, let's see if we get more fireworks. I'm hearing clicks. I see the green light on the 24-volt power supply. I see the red light over on the 12-volt power supply. So this EB832 is likely fixed. I'm going to reassemble, do some final testing, and we'll wrap up. Okay, so what have we learned today? Well, let's start with the original bad power supply. In addition to the blown capacitors, there was a problem somewhere else in the circuit that was causing the output DC voltage to variate between about 7 volts and 30 volts, or about 30 volts, so it was not stable. It wasn't very reasonable to just go and troubleshoot a power supply that's worth about $2. It's a very uncommon problem for this power supply as well. So it was decided that instead of fixing it, we're going to get a brand new identical power supply, swap the capacitors for new, better ones, and use that instead. When we did this, the power supply blew up. What I originally didn't notice when I unpacked it is that this pre-filter coil over here, plastic, is damaged. So my best guess what happened here is that that coil shorted somewhere, and the short caused the power supply to short on the AC side. That's why we saw fireworks. There is damage over here on this resistor. There is definitely damage across this coil. So something here caused the problem. You can see that the coil is slightly melted as well. So there was definitely a short going. So we had to junk that power supply, replace, get another one, and put new capacitors on the new power supply. And after that, the EB832 is working again. This teaches us an important lesson. these are inexpensive power supplies. We say that these power supplies are still okay to use in EB832, and they are. However, when we get brand new ones, the first one we get out of the pile may or may not work. And in this particular case, it clearly didn't. And I'm happy that I tested this power supply prior to install it into the EB832. This is why when I do repairs for any of you guys, I never ever ship things back until I fully test it, because you don't want things like this happening with just replacing a component and sending it back. So this completes the repair. Hopefully you enjoyed it. If you did, please like and subscribe, and I'll see you next time.